Hey guys, welcome back to my channel. Today we will be detecting a cycle in a linked list. So basically there will be a linked list and you will be given the head of the linked list. Now you need to know whether you got a cycle over there. A cycle is simply a loop in a linked list where you would be, linked to the same number in the backward. Like for example, it can be 2, 1, or anything, but you would just recursively loop through the linked list and there won't be an end. It's that simple. So that means a normal linked list would stop somewhere at a point like 1, 2, 3, and 0. So that would be a stopping point for here, but for this one, there won't be any stopping point. Alright? So here, a cycle does exist, it keeps going back, keeps recursively, like 1, 2, 3, again 2, 3, 2, 3, 2. So there is a cycle over here. And you have to return true whenever you get a cycle. But you can simply return false whenever you detect there is no cycle. So that's how you would be detecting a cycle in a linked list. Okay? So the best approach for this is something called as Floyd's cycle detection algorithm. Alright, so let's have a look. In Floyd's cycle detection algorithm, we would be using 2 pointers, slow and a fast pointer. Alright, the speed of these slow and fast pointers, the slow would be moving 1 step, but fast would move 2 steps. Alright, so this is called as a Floyd cycle detection algorithm. Why it simply works, let's have a look at these examples. So over here, it's like a hare and the tortoise. Okay, so let's have a hare and the tortoise in a race. So let's have a hare. Let's have a hare. Imagine this is your hare, and this is a tortoise. Let's have a number line. Imagine this to be your linked list, and this is your finish line. Alright, so let's start moving. So we got a hare and we got a tortoise. So first, they both are here. Alright, and now they both start the race. So your hare would be 2 points ahead of your tortoise, and your tortoise would be only 1 step ahead. Now your hare would have already reached the end point, but your tortoise would just come to the second point. Let me write numbers and do it once more so that it will be easier. Imagine this is your tortoise and this is your rabbit or hare. So both are at the same line. As I already mentioned, that the hare would be 2 points ahead and the tortoise would be just 1 step ahead. Now the hare would have already completed the race, but the tortoise is just 1 step ahead. Alright. Now you can already see that the hare has already completed the race. Now this is a non-cyclic racetrack. Let me draw a same racetrack but with a cycle. So they keep going back to the same place. 3, 4, but you will not be reaching the end. You would be going back towards the 2. Okay, now let's draw another tortoise and a hare. In this case, you can see that this is a tortoise. This would be here, and this one 2 steps ahead. Now, this would be at 4. Wait a minute. This one would be at 2, 1 step ahead. Now 2 steps ahead, 4 would be at 2. But when it reaches 2, you need to remember that 4 to 2 is just 1 step. So 2 would be here. Alright. Now move the slow. And you can see that both of them are meeting at this point. They are meeting. So once they meet, you know that there's a loop. Because hare always wins tortoise. But here, hare is at the same position of the tortoise. That means there is a loop. Let's make the hare to come back to that position. Let's have a look at the same concept in a linked list. In a linked list, you need to remember that you always need to have your slow pointer as well as your fast pointer at the head of the node. Right now, both of them would stop moving. At first, slow would move 1 step ahead and fast would move 2 steps ahead. So slow is here and fast is here. But as slow starts to move, you can see over here, fast dot next is already null over here. So you can immediately say that this is not a cycle. In this, you have your slow and fast over here. Slow would move here, fast would immediately move here. 4 and then null, okay? So you got a number over here. So next, you can see that immediately fast lands to null. So you need to make sure that in your conditions, you need to make sure that you're checking both of them. You're checking whether your fast becomes null as well as fast.next becomes null. Okay? And you also need to make sure that while writing this condition, you need to make sure you need to make sure that you do check your condition that slow is equal to fast, and when they become done, you need to return true immediately. So let me show you the coding. This is a Boolean function that is returning true or false. It has 2 nodes, slow and fast. So slow and fast both should point towards the head, that is the starting point of this linked list node. You need to also make sure that you write your while conditions, that is the stopping conditions, That is, you need to make sure that your fast is not null as well as fast.next is not null. And then you need to move one step using slow and two steps using fast. And if at any point, if both of them are the same, you need to return true. Otherwise, you can just return false, indicating there's no cycle.